this is lesson 18.1 on the Pythagorean theorem. Now, we already probably have learned the Pythagorean theorem, so we're going to start with that. Hopefully it'll just be a reminder. Now, these are the 18.1 notes. We're starting a whole new unit, so you need to print off a whole new unit or come and find, grab some at the school here. We have 18.1, which is the Pythagorean theorem, 18.2, Introduction to Trig, 18.3, find the missing sides with trig, 18.4, finding missing angles with trig, and 18.5, angles of elevation and depression. So we're going to be dealing with those units, and we're going to start with 18.1. Make sure you get your notes and then fill them out with me as you participate in the lesson. All right, Pythagorean theorem. So here we have a triangle right there. You're looking at the triangle. I'm going to find a color here. So these two sides are what we call legs. Now, we use the Pythagorean theorem in order to come up with a measure of one of the sides, either the legs or the C, which we call the hypotenuse. So it's missing side measures or sides of a right triangle. If we're missing one, we have to have two. If we have two already and we only need one of the sides, then we can use Pythagorean's theorem to come up with that third side. So what we call side A and B are legs, and they form the right angle. So always note that the legs are the ones that form the right angle. Side C, which is if you locate the right angle, go look directly across from that, you see side C, and side C is called the hypotenuse of the triangle. All right? So we have two legs that form the right angle, and then we have the hypotenuse that is across from the right angle. And for any right triangle, if you take the leg squared plus the leg squared, that's going to be equal to the hypotenuse squared. Now, sometimes you could even say A squared plus B squared is equal to C squared. That works too. But that's the Pythagorean theorem, and I'm sure you've figured out problems already using it. Here we have some triangles that are missing the sides. So as we know, we use the Pythagorean theorem to figure out the side measure. Now, what I'm going to show you really quickly is on these two are a little setup that will help you. Here we have the two legs and we're missing the hypotenuse. So the hypotenuse squared is always the one that goes on the side by itself. X squared is equal to 8 squared plus 13 squared. Those are the two legs squared. And undoing that means that you have to square root x squared. That's the only way to undo an x squared. So in doing that, you see that x, the hypotenuse, is equal to square root of 8 squared plus 13 squared. And for that, I would use the calculator. And I would always set it up that way. I would just make sure that I have the square root of the leg squared. And then you don't have to go through all this jibber-jabbish of solving for x on the Pythagorean theorem. So in that case, you have square root of 64 plus 169. And that is 64 plus 1, radical 233. All right, so radical 233. All right, now that is what we call an exact answer. Square root of 233, that's an irrational number. If you want to figure out what it is as a decimal, you're going to have to use your little toggle button on your calculator. And the square root of 233 is 15.26. It says round to the nearest tenth, so that's 15.3. That's just one place after the decimal, and if a 6 follows that, then it moves up to 3. All right, so the next one is a leg that we're missing. So notice, oh, dang it. That's weird. Oh, no. Huh. All right, so when it's a leg that's missing, then it's not the hypotenuse, and we have to come up with it a little differently. Let's Let's see if I can do this without messing up this time. All right, without moving it. So it's the leg we're missing here. And if it's the leg we're missing, then it's, dang it, why does it do that? Anyway, so you have 9 squared is the hypotenuse is equal to 7 squared plus x squared. Okay, I've been having problems with this all day, and this is the worst it's been. Why is it doing that? I don't really know. Anyway, you're going to subtract 7 squared from both sides, and you end up with 9 squared minus 7 squared is equal to x squared. Okay, and that gets everything on one side, and then we square root. So what you notice is, if it's a leg we're looking for right there, then it's the square root of the hypotenuse squared minus the leg squared. And that's what I usually do when I'm looking in my calculator for a side. If it's the hypotenuse, we use the square root of the leg squared plus the leg squared. If it's a leg we're looking for, then we use the square root of the hypotenuse squared minus the leg squared. And that means it's already solved. I don't want to say it's a shortcut because it's valid, but it just takes you to the step of where what you put in the calculator rather than using a squared plus b squared equals c squared and then solving for the side that's missing every single time. It's just a setup with the side already solved. So if you put that in the calculator, square root of 9 squared minus 7 squared, and that is 32. All right, now square root of 32 is 4 radical 2, but if you just, we're trying to figure out what it is to the nearest tenth, so we have to find the decimal approximation, and this is 5.65, and that bumps that up to 7, 5.7, because it's 5 or greater. All right, so for examples, if you have this triangle that we see on the next example, it's not just one triangle that's a right triangle with a missing side. Now we have a little more complicated arena with 3 triangles really, and a missing height. So this is your missing height. So you need, of course, 2 sides. Now, if these are, gosh, that's so crazy. If these are sides are congruent, then that means it's an isosceles triangle. And we have a hypotenuse leg scenario where both triangles are equal. And if both triangles are equal, each of these legs are going to be half of 22, so they're each 11. So that's how you would get your second side. You would have 11 squared plus 24 squared equal to, oh wait, that's not, sorry, I'm going to have to erase that, sorry, I'm getting distracted because it moves down so far. I wish I wouldn't do that. You have the hypotenuse is 24 squared minus the leg squared is equal to x squared, or under the radical. Dang it. Guess that works, sort of. All right, we'll just erase that. And then hopefully you can see that. So it's the hypotenuse squared minus the leg squared under the radical. If I put that under the radical, 24 squared minus 11 squared, it's in my calculator, I get radical 455, which is approximately, I'm going to just toggle it, 21.3. Okay. 21.3. Hopefully that's readable. Okay. The next one brings a few more steps into it. You're going to see that you have a rectangle here. If you draw an auxiliary line, which I hope doesn't move, but it did. Let's try that. So this rectangle is going to have the same measure on that side as it does on the right side. So you have 2 sides that are x, and then you have 2 sides that are 5. Of course, that didn't move there. Anyway, this side is also 5. which you're going to have to use your imagination. So if that's 5, then this side is 13 here, because the whole side's 18. So from here to here is 13, here to here is 16, and we're looking for the right angle of a triangle with a side of 16 and 13, and we need that. So we have 16 is the hypotenuse minus 13, which is the leg. We're going to square them and put an... Okay. So in the calculator, 16 squared minus 13 squared under the radical is radical 187. Oops, just 87. Radical 87. And if you toggle it, you get 9.32. All right, or 9.3 if you're rounding to 1 decimal. I'm sorry, that keeps moving. It's hard to see. Oh, what were we trying to find? Was that x? Yeah, we found it. Okay, I didn't know if we needed to go back and figure anything else out. All right, the next one, you have x is the length of that big triangle. Now, we don't know if it's a right triangle or not, and but we do know that this is a right triangle. Please don't move, please don't move, please don't move. Ugh. We know that's a right triangle, so we're going to find this x of this triangle. So that's going to be the square root of the hypotenuse squared minus the leg squared, right? And that's going to give us this section here. So square root of 29 squared minus 12 squared is approximately 26.4. And then here we have another right triangle because of that angle right there. And we have a hypotenuse of 14. So 14 squared minus 12 squared is going to be the other side, which is this part right here that we're looking for. We know this part is 26.4 between here and here. Now, square root of 14 squared minus 12 squared is 7.2. All right, and if we add those together, plus 26.4, we have, because this is 7.2, we have the whole side, which is 33.6. All right, so that's how you do that. I only have a minute before my thing's going to be gone, but this is the last one, so let's see if I can do it in a minute. All right, so a roofer leaned a 16-foot ladder. So here's my ladder, and it's 16 feet. Oh my gosh, this isn't moving. How lucky am I? Against a house. So here's my house. Okay, the 16-foot ladder is against the house. If the base of the ladder is 5 feet from the house, so that means here's the house, here's the base of the ladder, that's 5 feet. How high up the house does the ladder reach? So that's from the bottom here to this point right here, and that's what we're looking for. So draw a little picture. Lean a ladder up against a house. It's 16 foot, so mark everything, and it's sitting 5 feet away from the house, and therefore we just have to set up the Pythagorean theorem. What we have is the hypotenuse squared minus the leg squared under the radical already solved, because it is a leg we're looking for. So the square root of 16 squared minus the 5 squared is radical 231, which is approximately 15.2 feet away from that high above the grass for the house. And that is all of 18.1. All right, go ahead and finish the homework that follows. There's some, if I can find it here in enough time. The homework will follow right there. So you're going to just set up, if it's 2 legs, you set up square root of 10 squared plus 7 squared. If it's the hypotenuse you're looking for. If it's the side you're looking for, then it's the square root of 21 squared minus 19 squared. Subtract the leg squared from the hypotenuse squared. This one's a leg again, so it's the square root of 27 squared minus 16 squared. And then use those as you go throughout the homework. All right, good luck with that.